Here's a question from 2018. It says, in an arithmetic progression, the first term is a, and the common difference is 3. The nth term is 94, and the sum of the first n terms is 1420. Find n and a, and it's worth 6 marks. So the thing about an arithmetic progression, or an arithmetic sequence, is that each term is equal to the previous term plus something called the common difference. So you're always adding the same amount. It's like starting with 11 and then always adding on 4. So the next term would be 15, then 19, then 23, and so on. It's a very simple sequence, and there is some formula for it that you're given. And so this is what's given on the formula sheet. So it says the nth term is given to you by a plus brackets n minus 1 d. So it's the first term plus n minus 1 times the common difference. And s for sum of the first n terms, is given by this. A half times n times brackets a plus l, where a is the first term and l is the last term. But if you don't know the last term, it can also be given by a half n times brackets 2 lots of a plus n minus 1 times d. So we're going to use the information in the question and these formulas to set up a simultaneous set of equations for us to solve and find n and a. That's quite a lot of work, and that's why this is worth 6 marks. So let's use the fact that the nth term is 94 in here, and the sum of the first n terms is 1420 in here. So 94 is equal to the first term plus n minus 1 times 3, where 3 is the common difference. I've just substituted in d equals 3 and 94 for the nth term, and then rearranging this, we've expanded out the brackets, so n times 3 and minus 1 times 3, and then adding 3 to both sides, we get 97 over here, and if you take away 3n, we can write that in terms of a equals 97 minus 3n, and that's going to be one of our equations, which I'm going to substitute into the other equation, which allows us to solve these simultaneously. So the other expression was for the sum of the first n terms, and we know that the answer is 1420, and so that's going to be equal to a half n brackets 2 lots of the first term, which we don't know, plus n minus 1 times the common difference 3. So expanding, so substituting this into a, we're going to get then 1420 is equal to an expression only involving n, which hopefully we can solve. So expanding this out, 2 times 97 gives you 194. 2 times minus 3n gives you minus 6n, n times 3 is 3n, and minus 1 times 3 is minus 3. And all this inside these brackets can be simplified, so 194 minus 3 gives you 191, and minus 6n and 3n gives you minus 3n. Okay, let's continue this on the next page. So this was where we're up to. 1420 was equal to a half n brackets 191 minus 3n. And then what I've done is I've multiplied both sides by 2 to get rid of the fraction, and I've also expanded out. So n times 191 gives you 191n, and n times minus 3n gives you minus 3n squared. And rearranging this into the standard form, we get a quadratic equation, which can be solved using the quadratic formula, or in this case actually it can be factorized to give you this, 3n minus 71 and n minus 40 equals 0. So we're actually going to get 2 solutions out of this. One of them, though, is going to be a fraction. An n denotes the term number that we're looking for. So that has to be a whole number. So first term, n will be equal to 1. Second term, n equals 2. Third term, n equals 3, and so on. You can't have the 4.75th term. So n has to be a whole number. So that leads to not a solution. But n equals 40 is fine because that's a whole number. So n equals 40 is our solution. We also had to find out a, and so going back, we had an expression that related a and n, or n and a. And so substituting in n equals 40 into here, we get that a must be equal to minus 23. And that's the answer to the 6-mark question. So really quickly again, we knew the nth term and we knew the sum of the first n terms. This sets up 2 simultaneous equations to solve, and we found out that apparently the first term in this arithmetic progression was minus 23, and then each term after that was 3 more than the last. So it must have been minus 23, then minus 20, then minus 17, and so on and so on and so on. And if you work it out, the 40th term must be 94, and if you add up the first 40 terms, the answer must be 1420. So we solved a simultaneous equations to lead to a quadratic equation in n, which in this case could be factorized. We kept only the sensible answer, and from that we found out what A was as well. 6 marks. Here's another question, this time involving a geometric progression. It says the first, second and third terms of a geometric progression are, and we're given that they are 3k, 5k minus 6, and 6k minus 4 respectively. It says show that k satisfies the equation 7k squared minus 48k plus 36 equals 0. This is only worth 2 marks, and it's only part I of a question from 2019. So the thing about a geometric progression is that each term is equal to the last term multiplied by a constant. In this case it's called the common ratio. Another way to think about that is that the second term divided by the first term is going to be the same as the third term divided by the second term, because every single time you're multiplying by the same number, the common ratio. So using our first, second and third terms, I've got the second term divided by the first, this represents the common ratio, must be equal to the third term divided by the second term. So we've set up the problem. All we need to do now is cross multiply and expand, and then rearrange to get a quadratic. 2 marks. And here's part II from that problem. It says find, showing all necessary working, the exact values of the common ratio corresponding to each of the possible values of k. 4 marks. Okay, so we need to solve the quadratic equation. In this case it can be factorized, or you could use the quadratic formula. Now there's 2 values of k that are possible here. One value of k comes from positive 6 divided by 7, so k equals 6 over 7, and the other solution is k equals positive 6. Now I'm asked to find out what the common ratio is, and the common ratio is given by the second term divided by the first term. So this expression here, 5k minus 6 on top of 3k. Now if k equals 6 over 7, substituting that into this, we find that the common ratio, which is often given the symbol r, is minus 2/3. And the other solution, when k equals 6, substituting k equals 6 in here, we find the common ratio is 4/3. And that was worth 4 marks. There's a final part to this question, part III. It says one of these ratios gives a progression which is convergent. Find the sum to infinity. Okay, let's just quickly go back. So in one case, r was equal to minus 2/3, and in the other case, r was equal to 4/3. If we think about this, it means that starting with a number, the next term is going to be 4/3 times larger than the previous term, and the next one is going to be 4/3 times larger than that, and then 4/3 times larger than that. And this is growing because this number is greater than 1. When you multiply by something greater than 1, you make it bigger. And you multiply again and again and again and again, this is going to run away to infinity. We call that diverging. This case, however, where we're multiplying by minus 2/3, is we're multiplying by a number which is less than 1. I know it's negative, but it's less than 1 in size. And so what that means is we're going to be multiplying by it and getting a number which is smaller. Start with a number, multiply it by negative 2/3, you've made it smaller, and multiply by negative 2/3 again, you've made it smaller again, and again, and again. And this leads to a series which converges. So you're given some formulas for geometric series, and one of them is this one over here. It says S for sum to infinity, is given by a over 1 minus r. But it only works if r, your common ratio, is little. These vertical lines mean take away the negative. If it's negative, just keep the positive value. So negative 2/3 would just be equal to 2/3. And indeed 2/3 is less than 1, so this formula works. And being less than 1 just means that each time you're multiplying by a number which is less than 1, you're making something smaller and smaller and smaller. So summing up to infinity is given by a, the first term, divided by 1 minus r, the common ratio. But it only works if r is little, if you're multiplying by something which is smaller than 1 each time. So only for one of the cases 2 screens ago, okay, we had 2 common ratios here. This one is larger than 1 and gets large, so each term gets larger, and this one is smaller than 1 in magnitude, and so each term gets smaller. So only one of them has this condition that the common ratio in size is smaller than 1. And that was when k was equal to 6 over 7. So we have r, but we need to know what the first term is to use this formula. We need to know what a is. Well, going back all the way to the beginning of the question, the first term was given by 3k. So 3k, when k is equal to 6 over 7, is 18 over 7. So a must be equal to 18 over 7, r is equal to negative 2/3, and if you plug this and this into the formula which is given to you and work it out, you get a final answer which is 54 over 35. Okay, and here's a question from 2020. It's part A. It says the first and second terms of an arithmetic progression, so this is one where you're adding the same amount each time, and what you're adding each time is called the common difference. So the first and second terms are 1 over cos squared theta and minus tan squared theta over cos squared theta, respectively, and we're told that theta is between these bounds. It says, show that the common difference is minus 1 over cos to the power of 4 theta, and this is with 4 marks. Well, the common difference is just the difference between each term, and in particular it's equal to the second term minus the first term. So if this is the second term, minus, and if this is the first term, I have this to work out. And I need to somehow simplify that to get this. And I'm going to do that using some trig identities, but on the next screen. So this is what we're up to. The common difference was equal to the second term minus the first term. I have the second term here. It was negative this thing, and then I'm taking away the first term, which is this. So the first little trig identity I'm going to use that you should know about is that tan is the same thing as sine over cos, and that means tan squared of theta will be sine squared theta over cos squared theta. Okay, I've got to divide by cos squared theta on top, and so that can go downstairs and make that cos to the power of 4 downstairs. I have fractions, and whenever you have fractions, it's good if you can have common denominators, so you can then add or subtract them in this case. And so I want to make cos squared theta look like this denominator, cos to the power of 4 theta. And I can do that if I multiply top and bottom of this fraction by cos squared theta. And that's what I've done here. I've multiplied the top by cos squared theta and the bottom by cos squared theta. And now I have a common denominator, and I can go ahead and add these terms together, but I'll do that on the next screen. So this is where we're up to. We've got common denominators, and so let's write this fraction over its common denominator. I have minus and minus, so I pulled that out the front, which leaves me with one lot of sine and one lot of cos. So I've got sine squared plus cos squared theta. Remember, I factored out that minus sign. And here's the final little trig identity you need to know. Sine squared theta plus cos squared theta is equal to just the number 1 for any value of theta. This is called the Pythagorean identity, and it's very much like Pythagoras' theorem. But try it on your calculator. Sine squared of a number plus cos squared of a number always equals 1. And actually that's what we needed to show, that d, the common difference, was equal to minus 1 over cos to the power of 4 theta. With these kind of problems, it's always a good idea to change tan into the more familiar sines and cosines, so you have an expression involving only sines and cosines. And then try, if you can, get to a point where you have a sine squared and a cos squared, because that always equals 1. Those are the two little tricks that can solve most of these problems. Anyway, that was only part A. Here's part B. It says find the exact value of the 13th term when theta is equal to 1/6 of pi. Because this is given in terms of pi, we're obviously going to have to use radians and not degrees. This question's worth 3 marks. So we can find the 13th term for an arithmetic sequence using this expression here. It says the nth term is given by a plus n minus 1 times d, the common difference. Well, a is the first term, and we know what that is, and d is the common difference, and we know what that is as well. And so all we need to do to find the 13th term is plug in n equals 13 into this. So let's do that. So the 13th term is given by the first term, which you were given in the question. So first term and second term, yep, the first term is here, and also the common difference is that. So we've got the first term here, plus n minus 1, but I want the 13th, so 13 minus 1 times by the common difference, which in this case is negative. And I want to work out what is this when theta is equal to 1 over 6 pi. And we need the exact value, so a decimal won't work. Okay, when theta is equal to 1/6 of pi, plugging that into cosine, it's actually a special angle. It's cosine of 30 degrees, which equals exactly the square root of 3/2. If you tried that on your calculator in radians mode, you'd get a decimal here. However, we don't want cosine of theta, we only want cosine squared of theta and cosine to the power of 4 of theta. So squaring both sides over here, we get cos squared is equal to 3/4. So squaring the square root of 3 gives you 3, and squaring 2 gives you 4. And we also need cos to the power of 4, so I need to square both sides again. That'll give me cos to the power of 4, and squaring this, 3 squared is 9, 4 squared is 16. So all I need to do now is substitute in 3/4 wherever I see cos squared, which is here, and 9/16 wherever I see cos to the power of 4, which is here. And that's just a whole bunch of numbers which can be typed into your calculator, and the answer equals exactly -20.